All right, we are continuing our study of completing the square, but we're going to change things up a little bit. 7.6b is where a does not equal 1 in your equation. So the start thinking part says, what are the three ways we can solve the following quadratic equation? So when you're looking at this, you could solve that by factoring. As you see, you get one side equal to 0, which it already is. You do your ACB chart, you factor, you can do your shortcut on this factoring one, and you get an answer of -5 and 1. By completing the square, you find out what that magic number is that completes the square. It is half of b squared, so half of 4 is 2, and 2 squared is 4. So you have to add 4 to both sides. When you add 4 to both sides, now that left side factors nicely into x plus 2 squared, and the other side is now a 9. You square root, not forgetting your plus and minus for your 3. And when you say -2 plus 3 minus 2, or -2 minus 3, you end up getting -5 and 1. And then you can also solve by graphing. If you have Desmos close by, this is a great way. I was just doing this to check your answers. You just go over and get one side to equal 0. You graph it, and your x-intercepts are your solutions. So your x-intercepts would have been at -5 and at 1. We also have square rooting, but you can't really solve this by square rooting in the current form that it is in. Now this next problem says, Malachi is trying to solve the following by completing the square. He completes the standard method of adding b over 2 squared to both sides to complete the square. Foil the left side to ensure that the method works. If not, what might be the issue? So you can see they went over and did half of b, they squared it, that's 9. You put 9 on both sides, and then they said that it factored to be x plus 3 squared. But if you FOIL x plus 3 and x plus 3, you get x squared plus 6x plus 9. And that does not equal 2x squared plus 6x plus 9. So what is the issue? The issue is that you have an a value that is not 1. Your a value now is 2. And that is what we're working on today. It's basically, what do you do when you have an a value that is not 1? So let's take a look at this problem right here. It says, what are we going to do when you have the equation 2x squared plus 8x equals 5 because a does not equal 1. So what you need to do is you need to get rid of that a value. You need to make it into a 1. And the way you do that is by dividing by the a value. So here, you could divide by 2, 2, and 2 on all parts of this equation, and you end up getting to the place of x squared plus 4x equals 2.5. Now those two, if you bring yourself back to like one of the first chapters or units that we studied, we talked about equivalent equations. And the 2x squared plus 8x equals 5 is going to be equivalent to x squared plus 4x equals 2.5. Now, if you solve by graphing, they would look different, but the x-intercepts would be exactly the same, which means that the solutions to this would be exactly the same. Whatever the solutions are to that more basic one that only has an x squared will be the same solutions as the 2x squared. So now that you have that, you can go over and solve by completing the square. You find out what half of b is, which is 2, and you square it, and you add that to both sides. So now you have x plus 2 squared equals 6.5. You're going to square root both sides, not forgetting the plus or minus. And the square root of 6.5 gives you something really, really ugly. So I'm just going to leave it as the square root of 6.5. You would then subtract the 2 from both sides, and you end up with an answer of -2 plus red 6.5 and -2 minus red 6.5. And you could put those in your calculator and get your approximate answer of 0.55 and -4.55. Now, we could go over and test this out using Desmos. You would just put in the original equation, the 2x squared plus 8x, and then I'd probably get one side equal to 0 by subtracting 5. So you'd have 2x squared plus 8x minus 5 equals 0. And then I would put my cursor over the x-intercepts and make sure that they are 0.55 and they are -4.55 approximately. And here is that graph in Desmos. So if I put my cursor over here, you get -4.55 about, and you get 0.55 about. So -4.55 and 0.55. And if I pull this up, you could see those were the answers that we got. So the graph is a great way for you to check if your answers are reasonable. Now let's take a look at these next problems. The first one, you are going to divide by 2 on all of them. You end up getting x squared plus 3x equals 2.5. And that is now an a value that is not 1, so we can complete the square. So you are going to do half of b, and you're going to square it. and you get 2.25 is what you're going to add to both sides. I like seeing what it is before you square it because you know that that's what goes inside of your parentheses. So when you factor this, you end up getting x plus 1.5 squared equals, when you add the 2.25 to both sides, you get 4.75. And now you are going to square root, not forgetting the plus or minus. Since 4.75 does not square root nicely, I just leave it like that. And I have the two answers of negative 1.5 plus or minus the square root of 4.75. And once again, you could put in the equation 2x squared plus 6x minus 5, because you want one side equal to 0, into Desmos, put your cursor over the x-intercepts, and you will get 0.68 and negative 3.68 approximately. Now the next one is much more tricky. And the reason why it's more tricky is in the previous problems, when you're dividing by 2. And whenever you divide by 2, you get a really nice terminating decimal. Now here we're going to divide by 3. And you end up getting x squared plus 8 over 3x equals negative 2 over 3. If I go over and I change the 8 over 3 to the rounded version, well, now you're rounding, and you're going to be rounding off of a rounded answer. You're going to be using that answer and then rounding again, and you just keep doing it. So the way that you keep things exact is you leave them as fractions. Fractions in this case would be the exact, and if you went to decimals, it would be approximate. So on here, I have the x squared plus 8 over 3x equals negative 2/3. Now, while that is a different quadratic, it is equivalent to the original, which means when you graph it, the parabola is going to look different. It is still going to be the same x-intercepts, so it'll be the same exact solution. And when I say same x-intercepts, it's if you get the one side to equal 0 first. So on here, it gets a little trickier. And the reason it's trickier is because when you say, I want half of 8/3, well, how do you do that? I just multiplied by 1/2, and I got 8 over 6. And then I'm going to square that. But 8 over 6 reduces to 4 over 3. And when I square it, that's 16 over 9. So I'm going to add 16 over 9 to both sides. When you actually factor the left side, it is the x and then what you had before you squared it. So it's the 4/3. X plus 4/3 squared equals, and when I add 16/9, you can see in the bottom right hand corner of the screen, I got a common denominator and I added them together and I got 10/9. So when you add that 16/9 to both sides, the right hand side becomes 10/9. Now this is where it gets a little tricky. If you didn't think that was tricky yet. When you square root both sides, you square root one side and you get x plus 4/3. And then when you square it the other side, you can't forget your plus or minus, and you end up square rooting the numerator and the denominator. In this case, 10 is not nicely square rootable, so I leave it as rad 10. But the square root of 9 is 3. So that is why that side is plus or minus the square root of 10 over 3. And our last step is just subtracting 4/3. So I subtract 4/3 and you get negative 4/3 plus or minus rad 10 over 3. Now the only thing I did here was I go, oh, it already has a common denominator. Why don't I just go over and combine it? So negative 4/3 plus rad 10 over 3 gets you negative 4 plus rad 10 over 3. And negative 4 minus rad 10 over 3, you could see I made that my second answer. Those are the exact answers. Now you could put this in your calculator and get a decimal, but these are the exact answers. Now if you were to check it with Desmos, it would be better to put it in as a decimal, find out what it is as a decimal, because when you hover over those x-intercepts, you are going to want to see what it is as a decimal to see if it matches up. And don't forget, if we graph this, you want to get one side equals 0. So it would be 3x squared plus 8x plus 2 equals 0. And once you have that, then you can graph it in Desmos or on your graphing calculator. Now on this last problem here, students did this one. When you divide by 2, 2, and 2, you now get a different quadratic, but it is equivalent. And since it is equivalent, it'll have the same exact solutions. It looks a bit different, and if you graphed it, it would look different, but they would have the same x-intercepts, aka the same solutions. So once you get here, you're going to do half of b and you're going to square it. Write it down before you square it because you know that's the number that goes with the x when you are going to be factoring it. So it becomes x minus 1.75 squared because that's what half of b is. And then on the other side, you had to add whatever it was after it was squared. Luckily here, this is a terminating decimal. So it's 3.0625. When you add it on there and you square root both sides, it turns out that 10.5625 square roots nicely to what is it? I forget what it, let me see what it comes out to be. On second square root, 10.5625. It's 3.25. I probably should have written that. So that actually is a beautiful number, which is 3.25. That's what the square root of 10.5625. I really should have written that. So 1.56 or 1.75 plus that number, which is 3.25, and 1.75 minus that number, which is 3.25. And when you do that, you end up getting an answer of 5 and negative 1.5. And you could always put this in Desmos. The original problem, you would subtract the 15, so one side is equal to 0, pop it in Desmos, check your x-intercepts, make sure that you get the same thing. And since these are pretty answers, these pretty answers mean that you could have solved this by factoring as well, and you would have gotten the same answers. Now in this problem right here, problem number 2 on the right-hand side, those are not pretty answers. If you tried to solve by factoring, it just wouldn't work. When you solve by factoring, if you tried to factor this, you would not get a winning pair, which would mean it can't be factored nicely, and you wouldn't be able to do it. Same thing for number 1. If you tried to factor that to 2x squared plus 6x minus 5, because you get it to the other side, you would not get a winning pair. There is no numbers that multiply to get negative 10 and add to get 6. So since you couldn't do that, you wouldn't have been able to solve this by factoring, but you can do it by completing the square. Okay. Now let's take a look at the homework. This one says circle each of the following that have been factored correctly using the completing the square method. So on this one, you would do half of b and square it. When you do half of b, it's going to be half of 10 is 5, 5 squared is 25. Add 25 to both sides, and you end up getting x plus 5 squared. That works. The next one, you would actually have to divide by 3 before you did anything. So the fact that they did half of b and squared it, you can't do that. That's not going to work. And if you actually tried to foil the 3x plus 4 times 3x plus 4, you would not get 3x squared plus 8x plus 16. And the next one, half of 12 is 6. 6 squared is going to be 36. You add it to both sides, and then you ended up with a 6 inside of the parentheses. So that one did work. Now the next problem right here, I have already done my division. So this is as if the problem was 2x squared minus 5x equals 12. And then I had divided by 2 already. I just wanted to do the first step for you guys. If you complete the square with this one, you end up getting 4 and negative 1.5. Since those answers are nice, that means you could have factored if you wanted. You could also have stuck this into Desmos, and you would have an intersection. Remember, you got to get one side equal to 0 first, but you would have x-intercepts of 4 and negative 1.5. Number 3, you are going to divide by 2. You can divide by 2 before you add the 5 to the other side or after. It doesn't matter. So we're going to go over and divide by 2, divide by 2, divide by 2. You get x squared plus 1.5x equals 2.5. Remember, this is different but equivalent to the first equation, which means they will have the same exact solutions. When you do half of b and square it, you get 0.5625. And that's what you're going to add to both sides. But remember, before you square it, that's the number that goes in the parentheses. So it's x plus 0.75 squared equals, and you end up getting a 3.0625. When you square root that, you get nice answers of 1.75. So it's going to be plus or minus 1.75. Subtract the 0.75 from both sides, and you get your two answers of 1 and negative 2.5. Since those are pretty, that means that you could have solved by factoring. If they were like decimal answers that you had to round, that means you couldn't have solved by factoring. Now, I just wanted to show you guys the original graph of 2x squared plus 3x minus 5 is the red one. The graph of x squared plus 1.5x equals 2.5 is the blue one. While they're different, they have different y-intercepts. They have the one is wider than the other and so on. Doesn't matter. The main thing is that the x-intercepts are going to be the same. So this is if you did 2x squared plus 3x minus 5 and x squared plus 1.5x minus 2.5. You would have to get one side equals 0 again. And those are your two graphs that have the same exact x-intercepts because they're equivalent. On this one right here, this was just making sure you guys remember how to solve by graphing. When you usually talk about solving by graphing, you get one side equals 0, therefore the x-intercepts are your solutions. So the answers to A would be your x-intercepts at -2 and at 4. The next one is where does it intersect the line horizontally at 5, and that's at -1 and at 3. And then the next one is where does it intersect the horizontal line at 10, and it doesn't. So there's no real solutions. And then your last problem is just a review from something a long time ago. It says there was an 8% tax on non-food items in Petersburg. The total cost including tax was $68.58. What was the cost before? You can't just take 8% of 68.58 and subtract it away because that amount has the tax already in it. So you have to write an equation of cost plus tax equals total. Cost we don't know is X, tax is 8% of that, 0.08X, and the total is $68.58. They combine to be 1.08X equals 68.58, and when you divide, you get $63.50. And you could always try this $63.50 plus 8% of that, and you will get $68.58. All right, hopefully this made sense. The main thing is that if you go over and divide by the a value, you get to a place where it is much easier to solve using completing the square, and you have an equivalent equation. Sometimes the numbers come out to be nice, and you could have solved by factoring. Sometimes they're not nice. Like I said, these two problems here, 1 and 2, since those are ugly answers that we had to round, you wouldn't have been able to solve by factoring. If you tried to, you would have gotten something where you could not find a winning pair in the ACB chart. This always works, though, completing the square. All right, thanks a bunch for watching.